Hi everybody! Today's unit is going to be over graphing quadratics and using quadratics to solve. As we get started, we're going to talk about what a quadratic is, what the graphs look like, and then the two different forms that we want to focus on knowing how to use when we're graphing. So the first thing is, what is a quadratic? It is what you guys would probably know as a parabola, and it's kind of got that U shape to it. And I've got an example over here drawn, and I want to go ahead and label a couple pieces of a quadratic that are going to be really helpful as we get going with graphing. The first point we're going to be paying attention to is this point here called the vertex, and it's just an ordered pair, so x comma y, and the way you can identify the vertex is to look for the lowest or the highest point in your parabola. So in this case, the vertex would be the lowest point, but if the graph is opening down, then the vertex would be the highest point. The other thing that's going to be useful is the axis of symmetry, and the axis of symmetry is a line that goes directly down the middle through the vertex. I'll go ahead and label that axis of symmetry, or we would abbreviate that AOS. I'll usually use that more than actually writing it out. And this is a really unique line because this is what divides our parabola into two, and that can actually be very helpful when you're graphing. If you can find the axis of symmetry, then you can find points on either side very quickly because it's symmetric. So if you flip one side over the axis of symmetry, it should line up. The only other thing that you might want to be able to identify would be y-intercepts. So if you remember from lines, a y-intercept is where it hits the y-axis, and then eventually we'll talk about x-intercepts and what those mean. Okay, so those are the basics of the graph. The only other thing I would add to the axis of symmetry is that it does have its own equation, and I would want you to write that down. It's x equals opposite of b over 2a, and I'll explain where we get b and a here in a minute. The two forms we're going to be focusing on are the standard form and the vertex form, and I've written these out. I would encourage you to write these in your notes and have them to reference. Standard form is when you have all of your variables and constants on one side, and usually it goes from the highest exponent to the lowest, so it's typically x squared, then x, and then the constant, if there is a constant. And the letters in front of those, that A, B, and C, those just represent numbers. For example, in standard form, it might look something like this: 5x squared plus 2x minus 4. And so my A value would be 5, my B value would be 2, and my C value would be negative 4. Okay? And the other part of that standard form is the last number here. That is going to always be your y-intercept. So that's really nice because you can identify that point right away without doing any work. The vertex form we're going to get to here later in the notes. This form should seem somewhat familiar because we used it when we were doing transformations of graphs back in Unit 1. And we will go through that form in a later slide. But now we're just going to go ahead and get into the first example in standard form. We're going to start off by using an equation that's in standard form. I went ahead and I wrote 4 steps that would be really helpful to follow when you're wanting to graph an equation in standard form. The first one is to identify the y-intercept, and we just talked about in the last slide how the y-intercept is always that constant. So this number right here, that is your y-intercept. So I'll go ahead and write that the y-intercept is at the point 0, negative 3. So I'm going to go ahead and plot that. Once you find the y-intercept, you need to go ahead and find the axis of symmetry. And if you remember, we said that that equation was x is equal to opposite of b over 2a from the last slide. And we're just going to go ahead and plug in b and a into our formula. So here's a, here's b, here's c. So we'd have x is equal to negative 8 over 2 times negative 2. Simplifying that, we get positive 2. So this means our equation for the axis of symmetry is equal to x is equal to 2. And you could just go ahead and graph that line here, straight up and down, vertical line. And then we need to find the vertex. Now in standard form, vertex is not easily seen, so this is where you have to calculate it. And we said earlier that the vertex is on the axis of symmetry. So what we can do is use our axis of symmetry that we found in step 2 to help us find the y value. So we already know the vertex is going to be at 2, but we need to know where the y is going to be. So plug 2 into your equation, and we'd get negative 2 times 2 squared plus 8 times 2 minus 3. And if I simplify that, we'd get negative 8 plus 16 minus 3. So that's going to get us 8 minus 3, which is 5. So when I plug in 2, we get 5 out. And there would be our vertex point. So 2, 1, 2, 3, 4, 5. And I always go ahead and label it with a V just so we know it's the vertex. And then the last step is just to plot points. So at that point, you can just use your axis of symmetry and your y-intercept to help you. Remember, one side is going to be symmetrical to the other. So if I know that the y-intercept is 2 away from the axis of symmetry, then I know another point would also have to be 2 away. Or you could also make a table and plug in some points. Maybe you plug in positive 1 or positive 3 or something along those lines, 5 or negative 1. Just any ordered pairs on both sides of the axis of symmetry. That way you have a nice U shape. So if I plug in 1 into my equation, we'd get negative 2 plus 8 minus 3. That's 3. So I can go to 1, positive 3. And I know that the other side should match that. So when I plug in 3, I should also get positive 3. And now I've got 5 points. That's really all you need in terms of connecting your graph. If you get more than 5, that's great, but I'm only going to be looking for 5 points. Connect it so it has that U shape to it, and then you're done. And we could also tell that our graph is correct, at least to some degree, because our equation was negative, which means it should be opening down. That's a good way to at least check the direction of your points. If you have any questions over the 4 steps, make sure you let me know. I'd encourage you to try this one on your own. Y equals x squared minus 6x minus 1. Remember that this number in front, that's your A, negative 6 is your B, and then negative 1 is your C. So follow the 4 steps and then see how you do. The last form we're going to talk about in this video is the vertex form. I've gone ahead and rewritten that for you. But before we actually use it to graph, I want to remind you of a couple key things about this form. If you remember back from Unit 1, we could look at these graphs that are, or these equations, and tell which way they were translated. So remember, the number in front tells if it's a dilation, whether it enlarges or shrinks. The number inside the parentheses tells you if it goes right or left, and then that number at the end tells you if it goes up or down. And all of that should be reviewed from Unit 1. And then if I'm looking at this form, my vertex point is going to be whatever H and K are. So remember, if I told you this is my equation, then my vertex would be at the point positive 4, positive 6, because the number with the x always changes signs. So that's where I put here, it's always the opposite sign. Okay, so let's use this form to graph. This will be a lot quicker than our previous form. So I've got the example f of x equals negative 2 times x plus 1 squared minus 3. Of course, we really only have 2 steps here. Find the vertex and then plot some points. My vertex, if I look at my equation, is going to be at negative 1 and then negative 3. And we could go ahead and graph that. Let me get some graph paper here. So negative 1, negative 3. And if you wanted to, you could go ahead and draw your axis of symmetry in as well, because remember, it goes right through it. So the axis of symmetry would be at the equation x equals negative 1, because it has to match the x. And then the rest is just to plot some points. So make a table if you wanted. And I'd pick points to the left of your axis of symmetry and to the right. So maybe you plug in 0 and 1, and then also plugging in negative 2 and negative 3. As long as you get a variety of points on both sides, that's all that really matters. If I plug in 0 into my equation here, I get 0 plus 1 squared, which is just 1. So I'd get negative 2 times 1 minus 3. So negative 2 minus 3 is negative 5. 1, 2, 3, 4, 5. And then if I plug in 1 into my equation, 1 plus 1 is 2. 2 squared is 4, so I get negative 2 times 4 minus 3. So negative 8 minus 3 would be negative 11. So that'd be way down here. And then I could do the same thing with the other ones. Plug in negative 2 into the equation. And when I do that, negative 2 plus 1 is negative 1. And when I square negative 1, I get a positive 1. So I get negative 2 minus 3 again, which is negative 5. So remember, it should be symmetrical on this graph. And then the last one would be down here to match the other point. And then, of course, we connect to make our parabola with the arrows, and we are done. So vertex, draw the axis of symmetry, and then find some extra points and plot them, and you'd be done. And that's it for vertex form.